Our next speaker is Dr. Anna Dilger. Anna started out as a Hoosier, maybe still considered a Hoosier, right? And started her academic career as a Boilermaker at Purdue, earning her bachelor's and master's degrees. She then attended the University of Illinois, where she earned her PhD in meat science and muscle biology in the lab of John Killefer and Floyd McKeith. Anna then began her tenure as assistant professor at the University of Illinois and was recently promoted to associate professor. Congratulations on that. Anna's research focuses on prenatal and postnatal factors that alter muscle development, growth, function, and meat quality. And Anna will be talking about oxidation of lipids as it impacts meat quality, right?
I think so. Maybe. All right, I appreciate the introduction and really appreciate the invitation to attend this meeting. I don't usually get to come to this meeting because usually the other Dr. Dilger gets to come to this meeting. And so it's fun to actually put faces with names for a lot of you. And I'm also really happy to be following up after Eric, who I think established really nicely that lipid peroxidation in our diets matters, right? And it really matters in terms of pig performance in the nursery. And so we are going to now shift to the other end of this pig's life. And talk about the implications that this peroxidation may have for actual product quality, the pork that we put in people's mouths at the end of the day. And so before we get there, I just want to make sure that we're all on the same page of why in the world we would care about oxidation when it comes to meat quality. And so I'm sure most of you are aware that meat, like all foods that contain lipid, undergoes oxidation during storage. And that oxidation deteriorates the quality of that food. And you have probably all experienced this in that you have found in the back of your cabinet some potato chips and decided to eat them and then regretted your decision, right? Because they were stale and kind of tasted sour or gross. And so we call that rancidity, right? And so that development of rancidity during storage makes food not taste so good. And so really when we think about establishing the shelf life of meat, we care more about the overall eating quality of that meat than we do about the microbial quality of that meat. We've gotten really good in the meat industry at cutting down the level of microbes on meat such that most of your sell-by dates are really determined by shelf life dependent on oxidation. And we'll talk about why that is in just a second. But the reason that I'm here talking to all of you today is that the diet can influence the rate and extent of oxidation that occurs during the storage of meat. And two ways that that happens. The first is increasing the content of unsaturated fatty acids in meat. Just like Eric told us, as we increase the amount of unsaturations in our fatty acids, then we will have fatty acids which are more prone to oxidation. This has gained a lot of attention over the last 15 years as overall our swine diets have become more unsaturated in nature, especially with the inclusion of DDGS and other types of fats into our diets. And so we've been talking more and more about this as meat scientists when it comes to the shelf life, especially of things like bacon. And it's good to be a meat scientist because in the end we actually get to eat our experiments, and so it's pretty nice to eat that much bacon. The other way that we can actually increase or have the potential to increase oxidation in our meat products is by feeding fats which are oxidized. And as we feed those fats which themselves are oxidized, if that oxidation makes it past the liver and actually is deposited in tissues, we actually start out at the beginning of our shelf life with a higher level of oxidation than we would anticipate. And as Eric also explained, lipid peroxidation is an accelerative process, right? Once you start it, it goes all on its own. And so if you start out with a higher level of oxidation, you can potentially have an increased rate of oxidation. And so both in these ways, we can have a dietary effect on meat shelf life. And so specifically, when we talk about oxidation and meat shelf life, we're talking about two issues. One that you've probably heard a lot about is the oxidation of lipids resulting in rancidity. And so rancidity is that development of that kind of off flavor, kind of the weird smell. If you've ever had a batch of French fries from like Burger King or McDonald's that maybe they haven't changed the fry oil very recently and you kind of get that weird flavor, that's actually those secondary products of oxidations, those aldehydes and ketones that are imparting those off flavors. And this is especially worrisome when we talk about pork products which are relatively high in fat, things like a fresh breakfast sausage or some bacon. And so in a recent study out of our lab, we were interested in the shelf life of some fresh sausage. And what we have here is actually sausage which was stored frozen for 12 weeks in an oxygen permeable package. So just kind of a styrofoam tray overwrapped with a PVC overwrap. And as you can see, you can store it in the freezer for 4 weeks and everything's fine. But if you store it in the freezer for 12 weeks, we actually have a pretty dramatic increase of off flavors. And in that line there, above the orange bars of off flavor is actually our T-bars level. And so you see our off flavors actually keeps really nice pace with our T-bars. And so when we think about limiting shelf life with rancidity, most of the time on things like bacon, the sell-by dates that you see on bacon actually have to do with the development of rancidity and not the development of microbial contamination. Because as processors, we would like to present our products when they're at their peak. And we don't want to serve people bacon which would be rancid because chances are they're not going to come back and purchase our bacon again. And so this means when we have to shorten up our sell-by dates, as we've had to in the industry recently due to this issue of rancidity in bacon, retailers tend to discount or even dispose of products that are close to their sell-by date, which then contributes to food waste. That's a perfectly safe product that could have been consumed because rancidity isn't a food safety issue, but it is a product that people don't want to consume. And so the other reason that this is important is most of you are probably purchasing bacon that looks like they're in that yellow package, even though it's a really big package of bacon. But that is a retail package. It's vacuum sealed. You're really limiting the exposure of that product to oxygen. And so the chances of it becoming rancid are very poor. And you can usually store that bacon for up to 120 days under refrigeration and not have a problem at all. But if you had bacon this morning at your hotel or at a restaurant, it wasn't packaged like that. It was actually packaged like you see here in this box. And so it's laid out on parchment paper and it's stacked up, and it actually doesn't have any oxygen barrier at all. And so the shelf life on that bacon, even under frozen conditions, can be as short as 90 days. And so recently there's been a lot of issues that this bacon is going bad before people can use it. And so we are really concerned right now with unsaturated fatty acids in things like bacon, and also the concept of lipid peroxidation. And so rancidity is probably something that you've heard about. It's something that's become a big issue in the last 10 to 15 years in the pork industry. But something that you may not be aware of is actually the oxidation of proteins. And so in addition to lipids becoming oxidized with storage, we can also oxidize certain proteins in meat. And actually, if you increase the rate of lipid oxidation, it will also increase the rate of protein oxidation. Those two things go hand in hand. And in particular, we're worried about the protein myoglobin. And so you might remember from a basic meat science class, how many ever years ago, that myoglobin is really important when it comes to meat color. And so meat color is all derived from the particular state and form of myoglobin. And so if you take a piece of meat out of a vacuum package, usually that's a very dark red, almost a purple color. That's the state of myoglobin called deoxymyoglobin. If you set it out on the counter for a little while, it will pink up or red up. It'll go through the process of blooming. That's called oxymyoglobin. In both of those situations, that heme ring, that iron in there, is actually in the reduced state. But exposure of that product to oxygen and then to transition metals or with time will actually oxidize that iron and lead to metmyoglobin. And metmyoglobin is brown. And I don't know about all of you, but I'm not terribly excited about eating brown meats, and neither are consumers. And so what we have here on top is actually beef, and on the bottom is pork. I put beef up there because it's relatively easy to see the color change with metmyoglobin in beef. And so you can see the difference. Oops, we need some lines. Maybe? Ooh, there we go. Now you see it. Aren't you glad we've already had lunch? Because this is super appetizing, right? And so as you can see, if you were shopping at the grocery store and saw some beef up there on the top, even the one that was about 20% discolored, not going to be terribly excited to purchase that. When we think about the formation of metmyoglobin in pork, on the other hand, sometimes it can be a little bit more difficult to see. Now that we've turned off the lights, you can see it pretty well. But you see the difference. Sometimes that metmyoglobin in pork almost is a little bit of a gray color. And so sometimes a little bit harder to pick up. But again, people aren't going to be terribly excited to eat this. And in fresh pork and fresh beef, this discoloration can, oops, wrong way. No. Can develop over a course of days of retail display. And so we would expect it to develop somewhere between 5 to 10 days in a pork chop. And what we have here is that same study of fresh pork sausage. And we can see after being stored in the freezer for 12 weeks, and then displaying it under refrigeration for just 3 days, those sausage patties were greater than 50% discolored. And I think we can all agree that a 50% discolored sausage patty isn't going to be selected and picked up by a consumer. And so again, when we have these problems with oxidation, it limits how long we can present products to consumers and allow them to buy it without discounting it or having to rework or throw away that product. And so now that we've established that, as meat scientists, oxidation matters, and that actually oxidation starts to govern our shelf life much more than microbial problems, I'd like to take it one step further and talk about the evidence that exists that these oxidized lipids and these secondary products of oxidation, when they are present in the diet, actually get deposited in tissues that we care about. And so Eric showed some data that indicated an increase in T-bars levels and a reduction in vitamin E when measured in the plasma. And so if you'll remember, back to basic nutrition, fatty acids absorbed from the intestine are transported as chylomicrons, processed by the liver, and then they're transported into the skeletal muscle and the adipose tissue by VLDLs and LDLs. And so when you measure the presence of T-bars in lipids, what you're actually, or the presence of T-bars in plasma, what you're actually measuring is oxidized lipids within these different kind of transport vehicles. And if oxidized lipids are showing up in chylomicrons and VLDLs and LDLs, then the potential is there that they are actually being deposited in the tissues as oxidized lipids. And so there's good evidence both from rats and humans, and also some older evidence from pigs that that is actually happening. And so labeled carbons from oxidized linoleic acid were then present in VLDLs in both rats, and then they were detected in skeletal muscle of rats and of humans. And so that would suggest that oxidized lipids and unoxidized lipids are handled exactly the same way. Right? Transported through the blood, deposited in tissues. And so if it came into the animal oxidized, while the liver can do some reversing of that oxidation, some repair of that, that repair is not perfect. And we do deposit oxidized lipids into our skeletal muscle and our adipose tissue. There's also evidence from Buckley et al. In 1989. He fed oxidized oils to pigs and demonstrated that mitochondrial membranes were less stable. Again, that incorporation of these oxidized lipids into mitochondrial membranes makes them less fluid and therefore less stable. In our own lab, we fed oxidized oil to pigs and demonstrated, in addition to changes in the serum, a depletion of antioxidant reserves in the back fat. And so we saw a reduction in back fat vitamin A, in this particular study, not back fat vitamin E, when we fed pigs at the level of 5% oxidized oil. And so thinking about this, the concept that oxidation matters in terms of product quality, and that there are good evidence that oxidized lipids are deposited directly in the tissues, we were really interested in whether or not there was enough of this oxidation being deposited in the tissues to really matter from a meat quality perspective. And so this is some older data out of our lab, published some years ago in JAS. And in this particular study, I knew I could not come and talk to you all unless I was going to present a diet table. And so, ta-da, nutritionist, here is my diet table. And so we had 160 pigs that were allotted to 32 pens. That's 5 pigs per pen for those of you who aren't good at math. They were fed these particular diets for the final 56 days before slaughter. We then slaughtered those pigs in our shop and then carried out all the meat quality evaluations. And so our 4 treatments, all the same diet, we just had 4 different treatments, either included an oil that was not oxidized, what we consider to be a fresh oil, or an oil which was oxidized, in much the same way that Eric talked about, heated, bubbling oxygen through it. And we reached an oxidation level of 150 milliequivalents of peroxides. And then when we mixed that into the feed ended up at about 7.5. And then we actually, very similar to what Dr. Van Houten talked about, also included an antioxidant. And so in a 2x2 factorial arrangement, we have either fresh oil without antioxidant, fresh oil with, oxidized oil without antioxidant, oxidized oil with. And this research was done in conjunction with Novus, and so of course we used their antioxidant. And so as we expected, has been really well established in the literature, when you feed diets that contain oxidized oil, you have a reduction in both feed intake and average daily gain. And for us, the reduction in feed intake and average daily gain were very similar, such that we did not have a difference in gain to feed. And interestingly enough, we didn't have any improvement in our feed intake or our growth performance in those diets that included an antioxidant. Because the pigs grew less, they had a lighter ending live weight, they had a lighter hot carcass weight, and they were less fat, simply because they were smaller and they grew less. And so overall, these were the results we expected. This was actually the second trial after we had done a previous trial in chickens. And in the broiler trial, it was very much like this. And so we were interested in now, we felt that we had established, certainly we had enough oxidation in our diet to affect our growth performance, but was it enough that we were going to see differences then in meat quality? And so we started by measuring the level of oxidation using T-bars in fresh loin chops. And these were loin chops that were displayed in map packages for 21 days. And we can see that starting at about 14 days, that solid orange line on top is our oxidized diet without antioxidant. And you can see that we have an increase in T-bars, an increase in oxidation starting at 14 days and continuing for 21 days. And in both our fresh oil and our oxidized oil, the inclusion of antioxidants reduced the level of our T-bars, and so reduced our level of oxidation. As you can imagine, at this point in time, we were really excited, because I told you, as we increase oxidation, then we start to change things, like the development of rancidity, and overall the discoloration of our products. And then things didn't go so well from there. And so you can see here, we measured discoloration of these same loin chops displayed for 21 days, and actually we had the greatest amount of discoloration in our loin chops from pigs fed fresh oil. Both oxidized treatments are there in the middle, and the best discoloration, or the least amount of discoloration, was from our fresh plus antioxidant. And so it does not exactly parallel what we saw in terms of T-bars. And that really, I think, is the crux of the matter in terms of oxidation research, is T-bars is one measure of oxidation. And as Dr. Van Houten told us, there's like 17 other measures of oxidation. And I wish I could tell you, if you have this level of T-bars, then your chops are going to turn brown in this amount of days. But the data aren't there yet. There's a lot of work to be done to move from the theoretical into the application. In addition to loin chops, we were also interested in ground pork because we knew as there was a higher level of fat in these products, there might be more of an opportunity for some of this oxidation to happen. And we actually saw no difference in the amount of discoloration which occurred under 21 days of storage of this ground pork. But as you can see, if we get out past about 7 days of storage, we're talking about products that consumers are not going to want to buy, in excess of 20% discoloration, regardless of the diet which is fed. In addition to the discoloration work, we, of course, as meat scientists, ate the loin chops. We actually did not eat the ground pork because there is actually only so much eating that you can do. And as you kill the pigs, you get both loin chops and ground pork at the same time. And so we chose to eat the loin chops. And unfortunately, our loin chops, well, I guess maybe fortunately, our loin chops didn't have any effects of oxidation. We actually did not see an increase in the amount of off flavors or off odors, despite the fact we did see that increase in T-bars in our loin chops. And so the only comfort that we can take from this is the fact that we are not different than other people. It's actually been pretty well established that if you feed peroxidized oils, either in the form of corn oil, soybean oil, or even oxidized rice bran, you have an increase in T-bars in your products. But not always does that increase in T-bars in your products actually result in changes in either the color properties or the rancidity of your particular products. The majority of this work has actually been done in loin chops. And as you know, loin chops are relatively low in fat. I mean, a really well-marbled loin chop is maybe going to be about 3 or 3.5% lipid. And so not nearly the 20, 30, 40% lipid that we see in some of our higher fat products. And so I think there is some potential that we might be running into some issues in some of those higher fat products. And so if I go ahead and sum up for you, when we fed oxidized corn oil at a 5% inclusion rate, it had an overall 7.5 milliequivalents per oxide level in the diet, we saw a difference in growth performance. However, that difference in growth performance did not result in products which consumers were going to reject, did not result in a difference in our overall product quality. And from that, we can conclude a couple of things. First, the liver is an amazing thing, right? The liver being able to detoxify these oxidized lipids as they're coming in, such that all of that oxidation is not being deposited in the tissues, causing us problems from a meat science perspective, is fantastic. Also, it's really interesting that the antioxidant in our situation was able to modulate the amount of oxidation that was being deposited in tissues, even though it did not alter growth performance. And so from a meat quality perspective, the overall growth performance of your pigs tells me very little about the overall quality of the products that's going to be produced from them. And so we'll still have to keep talking to each other in order to figure these things out. And so currently our lab is undertaking a study along with Dr. Brian Kerr up in Ames to really try to push the limits. And so our question is, can we ever introduce enough peroxidation into the system to get past theoretical from a meat quality standpoint and get into a problem? So we oxidize soybean oil from 2 to 150 milliequivalents, and then instead of at 5% of the diet, we fed it at 10% of the diet. My student, Martin Overholt, will be presenting some of those data in 2017, but so far I can tell you, when you feed 10% soybean oil, you make some really bad bacon. And so if anybody, really bad bacon. And so if anybody is interested in being a taste panelist, we have some bacon to eat and maybe some graduate students that are not terribly excited to continue to eat said bacon. And so with that, I'd like to say thank you, acknowledge Novus for partially supporting that study that I showed you, and I'd be happy to answer any questions that you have.
Thank you.